So I'm going to talk about the way from Semantic MediaWiki to Abstract Wikipedia to bridge the topic of this conference with my newest work. And when Bernhard asked me to give this talk, I was like wondering what to talk about. And my natural inclination was, well, I'm going to talk about Abstract Wikipedia because that's what I'm working on right now. But then Bernhard asked me whether I could give more of a historic overview as well of how Semantic MediaWiki, Wikidata, Abstract Wikipedia all fit together. And I first said, that's the same talk that I gave just recently at this SMWCon in Barcelona, when it was about 10 years of Semantic MediaWiki. And then he said, oh, you know, recently, that's 5 years ago. That's half a decade ago. And I was, oh my goodness, it is, time flies. So I foolishly agreed to give such a talk, and I wrote the abstract about it very quickly down and said, okay, here, we're giving a historic overview, we're looking into it, and I give more or less an updated version of that talk. But then I started working on the talk, and it went a slightly different way. So bear with me for the next half hour, 45 minutes. I will take you down a little bit the memory lane and rehashing the history of the projects like Semantic MediaWiki, Wikidata, Abstract Wikipedia. But I will also try to figure out, in a thinking aloud fashion partially, why certain things worked and how the future might look like. So I hope you will find it interesting. As Bernhard just said, I joined the Wikimedia Foundation in July to work on a new project called Abstract Wikipedia, which I will tell you about towards the end of my talk today. The mission of the Wikimedia Foundation is the following. Imagine a world where everyone can share in the sum of all knowledge. How well are we doing at this goal? Well, today Wikipedia it's a living, it's a big project. It supports more than 300 languages. It has more than 55 million articles in those languages. But when you look a little bit more in detail, you notice, well, those articles are very unevenly distributed. So you have on the one side, English Wikipedia with more than 6 million articles. And if you do the math, you already realize it can't be all the Wikipedias being 6 million articles, if only 55 millions in totals. Then we take a language like Amharic, spoken by more than 20 million people, and we only have 40,900 articles. So the sizes are very, very different. But it's not just, you know, the big Wikipedias, they have all the content. They're the small Wikipedias, they don't have much content. It's also even English. So let's take a look at English and compare it to German. So German has 2.5 million articles, English has more than 6 million articles. But the interesting thing is, if you look at the overlap of the articles, if you look at which articles are covering the same topics, the overlap is only 1 to 2 million articles. They are more than half of the articles in the German Wikipedia. Don't have a representation in the English Wikipedia, even though it's more than double the size. There's a lot of knowledge in the German Wikipedia, which is not exposed to English readers. And if you go down to the article level, it becomes even more stark. This is the English article about Marie Curie. It goes on for pages and pages. It's a small little booklet, basically, if you print it out and look at it. And then you have attached articles and so on. If you go to Amharic, it's literally a single sentence. And you see, even if you have the article count, you still have a lot of content missing. But even Amharic has tons of articles about topics that are not represented in any of the other Wikipedias. This is the article about Quantafurfur, an Ethiopian dish. So you have in fact, you have more than 20 million topics that have Wikipedia articles. And even the English Wikipedia has only about 1/3 of it covered. Most of the knowledge of the world is hidden away from the readers of the English Wikipedia. Even more knowledge are hidden away from the readers of other Wikipedias. There's tons of knowledge inside of the Wikipedias which are not exposed to a large part of the world's population, unless you speak 300 languages, in which case you have access to all the knowledge. So if you're asking how we're doing it, imagine a world where everyone can share in the sum of all knowledge. We're not doing that well. We have a lot of knowledge out there, but we don't have access to most of it. Can we improve that? And what is the core problem of that? The core problem is that the cost of Wikipedia, as we currently think about it, is the number of topics that we want to cover times the number of languages, because every language edition is entirely independent. So we need 20 million topics, 300 languages, 6 billion articles written in different languages. That's a lot of work. Can we improve that? The same question already led our work in 2005. So these are the folks I've been working with at back then the University of Karlsruhe, now KIT, even that name has changed. Foremost Markus Krötsch, Heiko Haller, Max Völkel. And we've been talking about, so Max has been working on semantic wikis already for a while. He made it. He wanted to make it a topic of his PhD thesis. We were all PhD students at the University of Karlsruhe for Wood-Studer, and we were working on different topics. But I knew that Markus was also a Wikipedian, just like me, but it didn't cross it our mind that we could actually combine our interest in Wikipedia with our work on the semantic web. So all of us were working in the semantic web area, and we were figuring out how to make those tools fly. This is very early in the days of the semantic web, and then in 2005 came a call for papers for the very first Wikimania. It was held in Frankfurt, and we were like, "Oh, that sounds interesting," and we just like, we would like to go there and present. And we had no idea how Wikimania would be like. I guess no one did, because it was the very first Wikimania. And we were thinking, what could we present anything there? So it was early 2005, and we were like, but how could we make our work of the semantic web and Wikipedia? How could we combine those things? I sent an email to Max and Markus, and we were like hacking down some abstract just the day before the deadline, and writing, and then we were suggesting like, okay, let's compare to other semantic wikis in the field, and let's come up with some ideas that we did. We didn't plan to write any code. We didn't plan to write anything. We were just making a suggestion of how to connect semantic web ideas with Wikipedia, because we liked Wikipedia, and we submitted it. It got accepted, and we were giving a talk there. And this was the slide from that talk. It was in the very first session after the keynote, on the very first day of the very first Wikimania in 2005. And we just wanted to see that, meet a lot of the people that we know from Wikipedia, and present this idea. And it was like Wikipedia and the semantic web. What are the missing links? How does this connect together? And the core idea there, and you'll notice the syntax actually is completely different than we have it today. The core idea was, well, let's take the existing links in Wikipedia. So this would be a link to Frankfurt in a Wikipedia article, and add an annotation to it, a link type, in this case, located in. And what we would be building there would it basically be a big table with triples where we have the page where we are on. So, and for example, this might be the page about Wikimania 2005, and then we have a link to Frankfurt, and we say it's located in. So we would say Wikimania 2005, because this is the page we are on. It's located in Frankfurt. So we have this triple. This is exactly the core idea that turned later into semantic annotations of semantic MediaWiki. We didn't propose the name Semantic MediaWiki. Maybe we did. I don't remember. you could trace it down. But we suggested just this, and this should be implementable in, I was famously saying back then, in 2 weeks it should be done, to implement the whole thing and deploy it to the Wikipedias. So our proposal was much less about a software extension. It was about having this deployed to the Wikipedias and make each individual Wikipedia a semantic wiki with its own semantic graph and so on. This again got later changed into a single semantic graph of Wikipedia, but this was the original proposal. We were saying make each of the Wikipedia semantic, then you can compare what the different Wikipedias say, how the graphs look like, and so on. Fortunately, a German company in the healthcare IT sector, DocCheck, was listening to the talk, heard about it, and they picked up the idea. And they were actually the ones who implemented them, the very first version. So DocCheck is a company that was founded in 1999, and they have considerably grown since they were implementing this very first version. I checked their website information just in preparation for this talk, and I saw that the stock value more than doubled in the last year. Go figure, having IT and healthcare during a pandemic is a very viable business. So DocCheck then released Semantic MediaWiki 1.0 on September 30th, 2005. And we were thrilled that this existed, that this was created, and that someone was picking up on our ideas. And over the following years, we took over more and more of the software development and fostered an open source project, and it grew from there. And the rest is, as you say, history. A lot of people joined during the time that we're helping, like that you still know and are still around, like Yaron Koren, Yaron Dedau, and many others. And Marcus and I were mostly continuing to work on it, more or less. And other people became much more prominent and much more active in the community. So I was still working on my PhD thesis, and we were flying to Barcelona for a project, for some project work. It was within the SECT project. It was Semantic Engineering and Knowledge Technologies. That was the name of the project. And we were working together with the legal department in Barcelona. And what they wanted to work on was legal ontology, something where people from where lawyers, where judges can look up information and get information that they needed at their fingertip. And we had to work on an ontology for that, being the ontology engineering partner. Oh, semantic knowledge technology. Thanks, John. John was one of the people one of the main leads on the SEC project. It's great to have you here. So it was my colleague Christoph Tempich who pushed me back then towards the idea, well, can we use this semantic wiki of yours to actually do the ontology engineering, to build the ontology inside the wiki and then to export it from the wiki, and then have people discuss inside the wiki of how to build the ontology. And the interesting thing about this push was that it changed our understanding of how Semantic MediaWiki could be used. Because until then we were thinking like, oh, this is going to be the thing that is going to power the Semantic Wikipedia. This is going to be for Wikipedia and that's it. But what Christoph basically turned it into was an application for a specific use case for ontology engineering, for collaborative ontology engineering. And this was very interesting. It's a topic that actually keeps on going. There's been papers by others in the same area of using semantic wikis for collaborative construction of ontologies and so on. So all this work keeps working and has fortunately been continued. And the interesting point about this is that basically Semantic MediaWiki as a system is actually a rapid application development system. You can very, very quickly go into and develop basically almost any application. And you probably experienced it too. Semantic MediaWiki has been used for all kinds of things. We used it, for example, for project management of several EU research projects, then after SEC, for writing the proposals, for actually managing the proposal during the run of the research project. The budget was tens of millions, and Semantic MediaWiki could be molded to be perfectly used for that. We could manage the partnerships, the meetings, the deliverables, the project milestones, the research profiles. We had beautiful visualizations of all of this that we could just copy and paste into the proposal papers and so on. We could manage the publications, how they're connected to the deliverables, how they're connected to the work packages. We could quickly create lists of publication, and during project review meetings, you could answer the questions from the project reviewers from the European Union very, very quickly, because we had all this data available in a way that could be queried. We could easily add new types of entities and connect it to an even bigger net. It was wonderful as a way to quickly create this kind of knowledge management, rapid application development system. I used it as a diary for many years. Every single day I entered something, and I used it as a research notebook. I wrote my ideas into it, connected it with the papers that I've written, connected it, and had pages for the people I've been working with and their interests. So I could quickly figure out, I want to work something in this area, who is actually working in this too, and it was all available for me. And when I wanted to add something, I could just quickly go add one. And I wouldn't even just call it a rapid application development system, but I would call it a pay-as-you-go application development system. And here's what I mean with that. So, for example, from my own diary, research notebook, I started to write my paper reviews when a conference asked me. I started to write my paper reviews into my wiki, and I could just connect the authors if there wasn't a blind review, or the topics, or the conference, and I had this quick connect, and I could quickly figure out, oh, there was this paper that I was reviewing in this conference. Where's my review for that? And find it very, very quickly. I could enter experiment metadata into that, paper drafts, my meetings, my travels. It was brilliant. And at some point, for example, so I had already a few pages, for example, about my mom, about other family members. It was to keep birthdays. So I had, for example, my birthday warnings were coming out of the wiki. I used it as a calendar, as a notification system, as a address book, and so on. And then I was doing some genealogical research out of curiosity in my own family. And, you know, I already had those people who were my family members in the wiki, and could just create a few more properties, and everything was being set up to have the most perfect genealogical research tool. I could add family members, I could add dates of birth, the birthplaces, and everything. And just whatever I needed, I had to develop this time, and I had the basic for everything there. Oh, okay. I was thinking, is there anything I should be doing? There was a question about the screen size. So I could use this as a genealogic tool, just basically out of the box with just a little bit of work. It was wonderful. I'm still running my own website using Semantic MediaWiki, and it does everything a blog is supposed to do, and it was just a few queries and connecting it and a few forms, and everything works wonderful. It has, you can sort by dates, you can sort by topics, everything is there, and all based on a Semantic MediaWiki. And there are a lot of people using this kind of thing. So the AFB website, for example, the institute that Marcus, Max, Heiko, and I have been doing our PhDs, still uses Semantic MediaWiki as their website technology. Or there's, for example, people who use it for, as you know, for keeping genetic data and to have applications for personal genetic tool sets. There are people like Marcus who use it for the publication metadata and publication organization. There are people who use it for conference organizations and to have the deadlines and so on, and to keep the information about conferences over decades now in it, and to keep it accessible and queryable. So Semantic MediaWiki is really in this extremely sweet spot of rapid application level. You can push it into anything you want very quickly. Now the thing is, this is all not actually a unique property. And remind you, if it wasn't planned, it was emergent from MediaWiki's flexible templating and extension system, playing together with the new semantic capabilities of knowledge representation, storing a knowledge graph in the pages of the wiki. We didn't plan to make a pay-as-you-go application development environment. We were planning to add explicitly accessible annotations into Wikipedia. The rest just happened unintentionally and unplanned. And there have been a number of technologies that allow this kind of super rapid application development. And all of these have been misunderstood or under-marketed. Let's take a look at a few examples. So famously, I never used it myself, there's Apple HyperCard, which was spoken and loved by many for this kind of power and flexibility. There's Emacs with org mode and other things where you can just, just write an extension. You can basically do everything from organizing your mail account to being a notification. You can do everything in that space. There was KMI with Compendium that had all this power that you can use in a knowledge graph and then do magic on top of it. MIT had a similar project called Haystack that was built on top of the early linked open data web that we could connect it and provide a browser to it and do all kinds of things. Some people that I've known have just used a REPL of Prolog or Lisp as the knowledge bases. So they just like Emacs is also running on Lisp, so you just have a REPL open all the time with persistent memory basically that they can store, and they can put new facts into it and query it. And I've seen them just using, as their knowledge base, as their assistant to ask for all kind of queries. The same way that I was using my Semantic MediaWiki diary, where I could get like, oh, I'm traveling to this city next week. Who do I know there? And it just gives me, I make a query and just gives me the information. And so they have been all these powerful tools. And most famously, and the one that really had actually a big breakthrough, that was Dan Brickman with the development of spreadsheets. Spreadsheets are completely underestimated by real programmers, because they think, there's such a spreadsheet, that's not real programming. But the fact is, spreadsheets have been used for some crazy powerful stuff. There are companies who are running billions of dollars of values through a spreadsheet that they can't touch anymore, that no one understands anymore. It's doing a lot of the analysis, a lot of work. You have cells, you have values that can be calculated from other cells. Then those cells can be used in decision makings and to create new spreadsheets, create views, to create dashboards. You can collect orders, keep inventory. You can keep the number of cases during a pandemic in a spreadsheet. There's all this amazing stuff that spreadsheets have been used for, and spreadsheets have basically created a class of non-programmer programmers that is probably the most widely used programming language in the world, if you think about it. It's definitely the most widely used programming paradigm in the world, far outnumbering, real programmers, people who know C++ and Python and so on. So this has been the one successful thing, but it has never been marketed as that, right? It's been marketed as, well, you can keep your budgets here, or you can have tables with values and so on. But in fact, it's been used for so much more, and it's super hard to pinpoint and market actually this more. And Semantic MediaWiki is no different than that, and it's even on the web, and it can be more collaborative. And so there's some amazing potential in that. And in fact, this all leads to what I call the ultimate nerd snipe. So what's a nerd snipe? A nerd snipe is an idea that is so compelling that if you hear it, you have to stop and think about it and drop anything else you're doing. It's called a nerd snipe based on an XKCD comic, where this happens on the middle of a busy road, and it's not particularly favorable for the longevity of the nerd being sniped. So, for example, for a nerd snipe question, why does a mirror switch the left and right direction but not the up and down direction? What's so special about left and right? So this is just an example, and you have to sit down. If you don't know the answer to it, you have to sit down and think, wait, and it will be really hard to follow now the rest of the talk before you actually take your time to think about this. So, as I said, SMW has been used for all kind of these things, for all these kind of projects, and the goal of what I call the ultimate nerd snap is a tool or a system that allows us to, in lack of a better word, to think better ourselves, like if you use it personally, or to think better together in a team. This goal has led so many companies and programs and projects down into this NerdScience facility that they're devoting their lives, and I've seen so many people trying to solve this problem of knowledge management for the person or for the team, and chipping away at parts of it and trying to figure it out. There are tools in this space like Evernote, Wunderlist, like Rome, that's a current new hottest contender. Google Wave was in this space of quickly setting up collaborative experiences that are super flexible, that you can do stuff on it. Other projects that have been in this area is, well, the original wiki by Watt Cunningham about having people work together, think together, write stuff together. The web itself is probably the most successful proposal in this space by Tim Berners-Lee about having a uniform address space where all kind of contents can live together and be connected to it. But before the web, there were already proposals like Ted Nelson's Xanadu, which was a much more stricter and more and really more powerful version of what Tim then simplified down to what the web became. Or you have Alan Kay with the Dynabook, which had this incredible descriptions and little user stories about how it helps the people think, how it helps the people develop the thinking and work together with it. You had Vannevar Bush with the Memex, going back into the 40s, 50s, where he was describing a system where you could have information at your fingertips from a large library and connect all these things. You had Niklas Luhmann with the Zettelkasten. We don't even have to be in the digital space for this. We could argue if Dynamics was a digital machine or not. You could go back to just, pieces of paper being organized in the right way to help you think, to help other people come together. Paul Otlet with the Mundaneum, where he was creating a classification system for all the knowledge in the world. Melville Dewey with the decimal system, where he was much more successfully creating a similar system. And really going even back to, Lady Ida Lovelace with the idea that computation can not only be done on numbers, that those numbers can represent thoughts, other things, ideas, images, words, text, and so on, and be helpful with a general line of thinking. And before this, Leibniz of the Characteristica Universalis, Ramondus Lull with the Ars Magna, and so on. All these are really the predecessors of this. Let's think better, let's think together, let's externalize some of our thinking, let's have with artifacts, with external artifacts, with procedures, with machines that can then mechanize part of it. And Semantic MediaWiki is a perfect embodiment of this powerful idea, as you all know, as you have experienced. Otherwise, I don't think you would be here. But here's the thing. Semantic MediaWiki rarely scales well if you set it up naively. One problem with all these generic, flexible, powerful solutions, not just Semantic MediaWiki, but with all of them, is that whenever someone identifies something that works really well within such a system, if you find something, oh, this is a really use case that works really well inside of a Semantic MediaWiki, that works really well inside the web or whatever, they might actually just cut it out, productionize it, package it, turn it into a more efficient, more effective local solution. As I said, I use my local Semantic MediaWiki as an address book, as a calendar. But really, address books and calendars are much better at being address books and calendars than Semantic MediaWiki is. And this happens all the time. This has a lot of advantages. The individual tools are simpler. They're simpler to market, simpler to understand, simpler to develop, simpler to maintain. And they do what they're supposed to do. It's part of the Unix philosophy. A set of small tools, each of them doing their thing really good, you might think. But there are also disadvantages. For example, you don't share the data anymore. If you have your address book here, your calendar there, well, the connection between birthdays and people suddenly has to be somehow built into the system, and it's not natively there anymore. You don't share functionality, you don't share data, and that's the same thing with Unix. So Unix, as I said, has this small tool theory, but as long as you stay in the Unix metaphor, using files, pipes, lines and files, all these tools work together. And each new tool adds more power to the ecosystem. But then for certain problems, you start to cut away. You start to build your own products. It's like a walled garden. You build an application that doesn't work on the command line anymore. That doesn't work with pipes anymore. And suddenly this application solves its problem even better, even more compelling for most of the users, because you don't have to buy into the whole system anymore. But it's at the cost of everyone else. The functionality that you develop is not there anymore. And that's what Facebook did to the web. That's what LinkedIn is doing to the web. Quora and YouTube. Hello. My daughter just woke up, and she might be sitting around while I keep talking. So you have all these walled gardens and applications that you're taking out the web from, that you're taking out of the web, and that you're creating your own. They are more compelling, they are easier to build, and the same thing is happening with all these big solutions. You're taking them out of the more generic system that can actually do all these things. It has all the benefits of being connected together, but you can easier market a single idea. You can have a better UX, a better onboarding experience, more efficiency, less code for the given experience, and all of these.
I don't see anyone.
Yes, Leila, I really have to talk now, okay?
I don't see anyone.
No, you don't. Okay.
Are you talking to yourself?
No, I'm not talking to myself. There are a lot of people watching right now. Sorry for that. Okay. But on the other side, on the downside, there was no plan for doing that with Semantic MediaWiki. We didn't really plan to have this. We didn't have no one guiding this great pay-as-you-go application development idea. This was not our original idea. This is something that happened where we stumbled into it as a community, where we discovered more and more features that Semantic MediaWiki could do. And we led more or less accidentally to this place where all these features play together wonderfully, where we have the semantic annotations, where we have the templating system, the categories, the Lua code, the user authentication system, the history of the wiki, the fact that it's exposed on the web. All of this together create an extremely powerful system. And Semantic MediaWiki can do everything, and it's super hard to market it for that, because you can't market a tool for everything, right? But as soon as you market it as a specific thing, for customer relation management, for project management, for publication metadata management, well, as soon as you do that, you lose the most important advantage of Semantic MediaWiki, because suddenly it becomes a specific thing. And those specific things are often better done with more specific tools. The power of Semantic MediaWiki is that it's not specific, that you quickly can add it to new capabilities. But this is something that is really, really hard to market, to explain, to sell. And also some of those emerging features, because it has never been planned to do these things, those emerging features play badly together sometimes, and they're not meant to be stretched as far as they are. The MediaWiki template syntax is not meant to be stretched the way I have seen it in many places. And the number of curly braces I have seen and pipes and so on are completely confusing in many cases, and super hard to maintain. assigning computed values to properties. That's something that has worked more accidentally than planned and anything. Propagating results of properties of computed values through the system and propagating it to other things is something that works more or less better. It's completely fickle and depends on which order you update your pages and who visits which pages first and so on. Putting data from large external data sets into a wiki is something you can do with a Semantic MediaWiki, but it's really not meant for that. Maybe it should be better by accessing those informations, pulling them in. It all creates a maintenance and synchronization nightmare, and also you can all do all these things. There's no one really looking at a holistic experience and breaking it down, making it simpler, and figuring out what the core magic is. It has to be distilled and pulled out. The other problem is that because of these, because of the complexities of the templating system and of the other systems playing together, the system is really very hard to maintain often. A single person can dig in really deep and create a wonderful and powerful interaction and application, but they're often becoming very badly maintainable if you're not that single person working on it. And the buzz factor becomes quite dangerously low. It is hard to train someone to work with the system. It is hard to make them really care for the right parts. This is not different from any of the other powerful systems I mentioned before. It works well enough as long as one single person is spending a large amount, or a small group is spending a large amount of their attention on it. It deteriorates very quickly otherwise, and becomes simpler, becomes breaking down, and then suddenly you have ask queries that don't work anymore, that don't give you the right results, that just sitting around and do anything and so on. And this is something that can hurt organizations a lot, this buzzword. They have to think about how to keep this thing maintainable, how to keep it sustainable for a longer term. And this is something that we need to improve. My understanding is that the professional services around Semantic MediaWiki, and some of them have been, and just Ada was just talking about this before my talk. We will have another talk just following me about those topics. And those are getting constantly better and dealing with exactly the situation. And this is something we really have to focus on in order to make the system better. So let's have a little jump in time to 2012. When we created Wikidata. So Wikidata could have been built on top of a Semantic MediaWiki, obviously. And this is something that a lot of people told me back then, oh, you should have just built it on Semantic MediaWiki. It would have been faster and so on. But there are a few things that made it much simpler to start fresh and, you know, to cut out this specific space that Wikidata would try to cover that is not Semantic MediaWiki. And this is exactly what I was been talking before. It's easier to cut out a specific product and to cut out a specific experience instead of building it on top of Semantic MediaWiki. So we have, in this case, for example, the approach to multilinguality that Wikidata has, that Semantic MediaWiki could have, but it would be a little bit more difficult. We have the no text approach. Semantic MediaWiki is a very power and flexibility is in the fact that you combine text and structured data in many cases. But Wikidata is pure structure. There's no text floating around. You have to have the rather complex data model with qualifiers, with references, and so on, which could have been represented in Semantic MediaWiki, but we thought let's have it not there. So we could just do it from scratch natively and have it a bit easier. In many use cases, I totally think that Semantic MediaWiki makes much more sense than using a wiki-based installation. In other use cases, using Cargo makes much more sense than using a wiki-based installation. And you know, you have different use cases which are particularly amenable to those tools, and you shouldn't regard them as competing, but rather as complementary, because they are dealing with different use cases better. I always wish that Wikidata and semantic media would have been growing tighter together. I think that semantic results formats is something that would really benefit Wikibase instead of re-implementing them again for the Sparkle endpoint. I see there is more and more work going into bringing Wikibase and semantic MediaWiki closer together. I'm super thankful for that. I'm really happy for that, and I've been watching that over the years. What Wikidata can provide to semantic MediaWiki installations, and that's completely independent of the fact that they have so much common history and genealogy and both built the MediaWiki, is the background knowledge. When I was doing my research notes in Semantic MediaWiki and my trip reports, it would have been super useful to connect those to more information about the cities, about the places. If I could automatically know in which country a city is, or a university is located in which city and so on, I could have gotten even more powerful answers to my questions, like when was my last trip to Slovenia? And it would only work, and it would work out of the box, and they wouldn't have to enter all this data into it. Why do I have to say into my own wiki that Berlin is in Germany, that Karlsruhe is in Germany, that Ipswich is in England? All of these things could just be taken out from Wikidata. We don't have to actually pull this all internally, and don't have to keep it up to date ourselves. If a country leaves the European Union, if the visa rules for certain countries change, I don't want to be the one updating it myself in my own wiki. I should just rely on an external knowledge base and pulling this in. This is what Wikidata can offer. And it can rely on a large corpus of knowledge that can be reused, that can be enriched in local information. The same is true not only for Wikidata, it's true for other Wikibases, it's provided for other sources of data, and frankly for any linked open data set or the other data sets on the web that can be just pulled in and used in Semantic MediaWiki. I think Semantic MediaWiki is completely right in embracing even more and deeper the connection with knowledge bases outside of it to allow it to locally enrich it, reuse it, query it, visualize it, and to make Semantic MediaWiki the central focal point for application development to benefit from linked open data, to benefit from data resources, and so on. The other component that Semantic MediaWiki brings to the table, besides being able to deal and manage large knowledge graphs and to provide a peek into them. The other component is to have code that takes the annotated content and derives new content, that does something with it. If I have a venue in a city, I don't have to explicitly tag the venue with the country in order to understand it, in order to query it. I could just tag it with the city and then pull in the information and have a query for the country of the city coming in from another place and connect it together. I can materialize more knowledge inside my Semantic Media and make it easier queryable. Or if you have 2 dates, one can use math and other extensions to figure out what's the day of the week for a given date. How far a place is from a country. You can all do all these things inside the wiki and can count it. There are many, many such functions one could write in your own wiki, which you could build a more powerful knowledge-based system. But why rewrite these functions every time? And even more, the syntax of writing functions in SMW, in MediaWiki, frankly, is a little bit wonky, the templating syntax, and it's hard to write functions and test them, document them, maintain them, and so on, because it's not really meant for this. To give one example of how you could look at Semantic MediaWiki as a focal connection point of application development for knowledge bases. This is an example from the Wikidata Sparkle endpoint. So here we have a query. There's no code happening. It's just a Sparkle query against the Sparkle endpoint of Wikidata. You have a query that displays you on a map ATMs in Munich belonging to the interbank banking network. Now, the map is being pulled from OpenStreetMaps and is being displayed. So we're connecting already with OpenStreetMaps just for the display of the result. The other thing is Wikidata doesn't have all the ATMs. They also are in OpenStreetMaps and they're available for another Sparkle endpoint. So what we have in Wikidata is the connection of which banks belong to which banking network. We don't have that in OpenStreetMaps. So we ask for the banks that belong to the interbank banking network, and then we ask OpenStreetMaps for the ATMs belonging to those banks and display this on our map, again coming from OpenStreetMaps. So we're connecting in a single query those two external knowledge bases and displaying them. And this is something that Semantic MediaWiki could beautifully do and beautifully use this to render the results in actually many different map formats, again, using the maps extension, using semantic results format and so on. So there's a lot of things that we can do here and to power this kind of applications from external knowledge bases and so on. Now, a new project that we are aiming for to start next year is called Wikifunctions. Well, the name is preliminary and the date as well. The community just voted to have Wikifunctions as the name. We still need to wait to get a legal approval. But we're planning to launch Wikifunctions next year. And this will provide a large repository of code, of functions that can be used in many different contexts. The expectations is that, you will need some code to take a date, for example, and tell you how far it was in the past, tell you what week date it is, and so on. And all these functions, instead of having to write them yourself in your wiki, well, you could just take them from Wikifunctions and then run it and combine those functions together, again, in this super flexible rapid application development system that Semantic MediaWiki is. So Wikifunctions should provide you with a lot of the functions that you might want to use, and should be easy to connect them and to execute them within your context. And we'll get even more powerful than that. So we can use the Wikidata knowledge base, do calculations such as what is the closest museum to a coordinate, or a timeline of programming language surrounding a specific date given in your wiki. We can have functions that take an image and, say, compute a color histogram, that take a geoshape and calculate the area it covers, a text and guess the language of it. We want to make code accessible to anyone. We want to give the power to run code and democratize it, give the superpower to everyone. And this is the goal that Wikifunctions really has. Functions are knowledge, and therefore functions are power, and the large tech companies know that. And they allow you to have access to some functions through their user interfaces. So for example, you can go to Siri and ask how many tablespoons how many teaspoons are in 2 tablespoons, and Siri will calculate you the answer, which is a function being executed at this place. Or you can go to Bing and ask, so what day of the week was the 30th of September 2005, which was the date when DocCheck released Semantic MediaWiki, the first version of it. And you see, oh, it was a Friday. So much to never release on a Friday. See where this ends up. Or you can go to Google and ask, what is the volume of a pyramid? And you get this beautiful user experience where you can enter, the base length, the base width, the height of the pyramid in a form, and you get the formula, you get the value substituted, you get the result calculated, you get a visualization of what you're doing here. This is a function being run. And the big tech companies are working on providing you access to more and more functions in more and more contexts, through the assistants, through the search interfaces, in many more places, in the sheets and so on. And what we want to do with Wikifunctions is basically create a large accessible repository of those for everyone. So here's a mock-up of the Wikifunctions main page. Who knows how it will look like. And then you come in and you have access to all these functions that you can run in many, many different contexts. So a few of those examples could be, for example, here we have a distance function. So it takes a geo-coordinate, it takes a geo-shape, and it tells you how far is the coordinate from the closest point in the shape, for example. Or you can have reverse, a simple thing that takes a string and just reverse the string. Something that currently isn't immediately findable on the web of how to do it, for example, and something that the programmer, again, can do trivially, obviously, but here we want to democratize the power to everyone. You can create color histograms, to take a picture and create a histogram out of it. This is the multiplication function, taking integers, returning integers. The interesting thing is here, we have several implementations for multiplication. One might be in JavaScript, one might be in Scheme, for example. One might be in something called composition, where we'll compose the multiplication implementation from different other functions that we have in the system. Now, the interesting part is, if you look at this, for example, all of it is actually language independent. You can have the same view on it in code in a different language. You can actually code without having to learn English. We want to further democratize access to coding and to code, so that everyone can understand what they are doing, that everyone can add to those things. So we want to have this large Wikipedia of functions, to integrate functions in your code for the IDE, to do code analysis on it, and to access the functions in many different modalities, and provide a large library of functionality to all kinds of programming languages, and so on. There's so much more that you can do. And as I said, functions really are knowledge. And because they are, they squarely fall into the mission of the Wikimedia Foundation, of Imagine a World where everyone can share in the sum of all knowledge. And the thing is, we are actually building this whole thing because we think that Wikidata, that Semantic MediaWiki, are not powerful enough to express what you need for Wikipedia articles. And this is a quick aside at the end, just to tie together with the Abstract Wikipedia idea. What we really can do in expressivity is narration, is reference by description, and is redundancy. To give one example, this is the Marie Curie article about, this is the article about Marie Curie in the English Wikipedia. And in all the languages that I looked at, and in all the larger languages that have content like German, Italian, Spanish, Chinese, Russian, Arabic, we all find this one fact about Marie Curie that seems to be important enough for people to mention it in all these different languages. You find it here in Arabic, in Russian, in Spanish, in Italian, in German, in Chinese, in Korean. And if you don't speak on any of those languages, then you're probably confused. And this is how you feel when you don't speak English and go to the web. And here in English, Marie Curie is the only person to win the Nobel Prize in 2 different scientific fields. And this is something you can't express in Wikidata. This is something you can't express in Semantic MediaWiki, really. And we want to be able to express this. So what we want to take is take a sentence like this and create constructors that allow you to have this kind of thing and say the only person that has won the Nobel Prize in 2 different scientific categories. So we have these constructors, which are supposed to be language independent, and this is a big bet if this really works out. And then we take those constructors, and it doesn't really matter if the sentence is this or this, you know. What matters is that you can also represent it in other languages. So we have all these constructors. For each of the constructors, we want to create functions that can translate it to natural language. And those functions have to be per constructor and per language. And then you can have the same content be displayed in different languages. So what we then have is Wikidata with the constructors, with the abstract content being in it. We have the functions being in Wikifunctions, translating the natural language, and you get natural language text that you then can use in the Wikipedias, and that you can use in the different language Wikipedias. And then we have those functions like only person that can render this abstract knowledge inside of the Wikipedias and make this abstract knowledge available in the Wikipedias, and therefore reduce the maintenance cost of the content in Wikipedia. The etymology of the word water is one example where we are building already. This is showing that Wikidata already has more and more lexicographical knowledge, which we will need in order to express the different texts in the different languages. So we are building currently a lexicographic. We started in 2018, and we will use this lexicographical knowledge then to create the texts from the Abstract Wikipedia and the languages of the different Wikipedias. And as I said, this was the same problem that we had 15 years ago. The cost of the Wikipedias is the number of topics times the number of languages. And we want to reduce this. We want to turn this multiplication into an addition, and therefore reduce the cost considerably into a space that can actually be taken up by the community. This is the goal of Abstract Wikipedia. Create only one abstract content per topic, create only one set of renderers or functions per language, and then use Wikidata and Wikifunctions to actually roll this all out and have it and have more knowledge available to more people. And the hope is that Semantic MediaWiki really can use not only the data from Wikidata, but also the functions from Wikifunctions in many different ways. You can use those functions to calculate more stuff, to use it in this idea of a rapid application development system, where you can then just benefit from a large repository of functions that you can pull in. I hope that you will help us with getting there, with making Semantic MediaWiki a showcase of the functions in Wikifunctions, of how to use this knowledge. Abstract Wikipedia will be the main use case to drive Wikifunctions, and it will drive to allow to have more people to share more languages. But everyone should be able to create functions, to access those functions and use them. So we want to allow more people to use and write functions. We want to allow functions to be used in contexts, such as Semantic MediaWiki. We want to allow more people to read more encyclopedic knowledge, and we want to allow more people to contribute more encyclopedic knowledge across languages, to get a little bit closer to the goal of the Wikimedia movement of a world where everyone can share in the sum of all knowledge. Thank you all for your attention. Thank you for listening. And sorry that I was running a little bit at time and don't have too much time for questions anymore.
Thank you very much.
Just one quick comment. Pauling did get a Nobel Prize in Peace. Peace is not a scientific category. So Marie Curie is the only person who got 2 Nobel Prizes in 2 different scientific fields. This was a statement. And this makes it also harder to express, actually. And this is also another reason why we need this, the expressivity that something like Abstract Wikipedia can provide. Okay.